Hi, I'm Pat. Okay, in this group of problems, what they want us to do is to evaluate the 6 trig functions that you've been learning about for the given quadrantal angle, if possible. Okay, and as you would have learned, these quadrantal angles just mean that the terminal side land on one of our axes. Okay, now for this one that I'll do in the video, the angle that they gave me was 0 degrees. But for any of them, so one that you're going to do on your own, of course, the way you'll start is the vertex of your angle is always at the origin, and the initial side will be along the positive x-axis. Now, for a different problem then, they'll give you a different angle measure, but mine is 0 degrees. So whatever angle measure they give you, you're going to start rotating. Remember, positive is counterclockwise. Negative is clockwise. Mine's 0. So my terminal side falls right on that same positive x-axis. Wherever your terminal side falls, then pick a point on that terminal side. So for me, I'm just going to pick this point right here, 1, 0. Now what's nice is for these quadrantal angles, you're going to be on one of the axes, so that point that you pick on the terminal side, you can make very convenient. For instance, if we're here, I'd pick 0, 1. If I'm here, I'd pick -1, 0. And if I'm here, I'm going to pick 0, -1, okay? So what you can do is just start labeling some of your known information. For instance, x equals 1, y equals 0. It's right from this point. And also try to label your r. If you remember, r is that distance from the origin to your point. So again, with these quadrantal angles, it's convenient to see that the distance here is actually just 1 for me. That distance from the origin to the point that you're working with, okay? So if you're on any one of these axes, your r will be pretty straightforward. And before you worry, what if I'm not on one of these axes? You'll still be able to get your r. Remember, we're using r for radius. You'll be able to find that radius of a circle using the Pythagorean theorem, okay? But once you get your x, your y, and your r, then you're ready. Remember what the question asked us is to find the 6 trig functions for this angle. So let's find sine, in this case, 0 degrees, right? So whatever angle you're working with. But it doesn't matter what angle you're working with, sine is always y over r. And that's why we've got our pieces of the puzzle all laid out for us right there. Because now you're just going to pluck that y value of 0, put it in the numerator, your r value of 1, and of course simplify 0. Sine of 0 degrees is 0. All right. Also, part of what you're doing here with this type of problem when they're saying to find the 6 trig functions is you have to know what the 6 trig functions are, right? So cosine might be next. Cosine of 0 degrees, cosine of anything, is going to be x over r. And then I grab the pieces of the puzzle that I laid out for myself. X is 1, r is 1, simplify, and I get 1. Okay? So as I just mentioned, you're going to have to know these different 6 trig functions. So maybe move on to tangent next. Tangent, I'm looking for tangent of 0 degrees. Tangent is always y over x. Look over to your pieces of the puzzle, and y is 0, x is 1, simplify to 0, right? Okay, what's the next trig function? There's no specific order, but maybe I'll grab cosecant, 0 degrees. Cosecant of any angle measure is going to be r over y. Let's see, my r is 1, my y is 0, and you're always supposed to simplify. I paused here for a second because 1 over 0, realize that that simplifies as undefined. And that's actually why the directions would have said to evaluate the 6 trig functions if possible. Okay. All right, next maybe I would grab secant. We'll get secant of 0 degrees, but for whatever angle you're working with, it's going to be r over x. My r is 1, my x is 1, simplifies to 1. And finally, cotangent. Cotangent, we're getting cotangent of 0 degrees. Cotangent is always x over y. My x is 1, my y is 0, and we're getting another undefined. Okay, hope that helped. Of course, try some on your own.